Hello everyone. This is the first tutorial to model a three-dimensional structure using FeaKALC. The structure in question is a warehouse with the twin portal frames. Each one is 28 meters with the valley in the middle there. The structure spacing or the spacing between the frames is 6 meters along the axis, so you can have another view at this shot there. Um, and gables, and you've got the valley beam is acting as a transfer to receive every second portal frame. Dimensional description is height is being 5 meters, 25 meters is the span, height of the summit is 6.48. Directly we'll jump into FeaKALC 3D. We have two panes that can be changed, of course, from 3D to XY, XZ, or YZ, or you can as well toggle the layout to get it all at one three-dimensional. But in this tutorial, we'll just navigate through the twin view. Click on frame and activate the orthopolar, and then we go draw. You can see the angles are multiples of 15s and the length is showing you live. So we just need to draw 5 meter tall column. Just click on 5 and enter. So we've drawn the first frame there. Now we'll need to draw the rafter, which is at 14 meters distance. And then we go up by 147 just to draw the rafter there. Select those. It is being drawn here. So we'll just select this one and then click on array to replicate at X being 28 meters, which is the first portal frame, Y 0, Z 0, number of copies is just one. So that is what it says. So you need to replicate at X by 28, nothing to replicate at Y, nothing to replicate at Z. And then we'll draw the frame or thereafter on the other side. Now we'll select that all and then again use array replicate at X being 28 meters, nothing on Y, nothing on Z, number of copies being one. So that is our basic frame there. Now we'll go to the 3D view and select the frame, click array, nothing to replicate at X at this time. Now we are replicating at Y. So the spacing between the frames is 6 meters, nothing at Z, and number of copies is 7. 1, 2, 3, 4, 5, 6, 7. So we've got 1, 1, 2, 3, 4, 5, 6, 7, 8. We've got another frame missing. So we can again replicate that. Use Control to add to the selection and Control R, nothing, 6, 0, 1 copy. So all of the frames are now drawn. We'll draw the end beams. You can do this. Another one there, another one there. Double click to finish drawing and then select the 3 of them and then again Control R, Y being 6, 0, and then we've got number of copies, 8 copies, because we've got 1, 2, 3, 4, 5, 6, actually 7 copies, and then we say OK. So that is the first basic frame that we've got. Now, if you noticed that we don't have columns here and there, so every second column will be deleted just to maximize the space as required in the structure. So you can navigate either to select them in the 3D and delete them. So you just like select and delete, which is very convenient. Or you can go to YZ plane and navigate to the plane in question, which is this one. And then every second one should be now. select it and delete it. So that is our basic structure. Now we need to model the gables. So we will divide those into 1, 2, 3, 4, 5, and another 5 there. So let's see how we can do it. So go back to XZ, and we just navigate to the first one there, draw assisting line, and then select it. Now we can click on this icon, which is to divide it by 5. So the whole thing has been divided by 5. You can now draw just as whole frames, just like what I'm doing, and then select them, and then divide again with the intersections. So they've been divided now. Hit exit, and then delete the excess, delete the excess as well. Now we'll take those, Control R, again, X being 28, 0, 0, 1. Now they've been replicated, and now we'll take another one there, replicate at Y at this time. The distance at Y is 48 meters because that is the other end. 0 there, number of copies being 1. So we've got them all drawn. Now just to make sure the connectivity is right, so just select on all the frames and divide everything using the intersections. So now you can see the nodes have been drawn. Last thing is to do is to draw the Warren truss that we've got on that location. So how do we do that? So we've got now this distance is being 5.6 meters, 5.6. So what we are going to do, we'll take 2.8 from here and another 2.8 from here, and then we'll draw one frame at the bottom, and then projecting lines vertical to intersect with the rafters at the top, and then we can get the nodes worked out without any problem there. So this is what I'm gonna do. So I'm gonna go to this frame there. I'll go 2.8, 2.8, and then escape, and another 2.8, and escape, and then I'll draw another frame from here to there. So how many divisions? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 divisions. So I'm going to divide this by 9. Sorry, here by 9. And then just show the nodes to know what we are doing. Draw those frames nice and clean. You can replicate, of course, but just now probably easier. Select everything, divide at intersections, and now you've got the top chord now, or the rafter has already been divided, so I don't need any of those frames now. So let me delete them all together, and those as well. And this one, we don't need it. So what's happening there, if you just show the nodes at the top, they have already been made ready. Now you can, just looking at what we've got, you can go up and down on the 3D. Just go as it shows here. Use shift to pan. When we go, the nodes are not visible, but you can snap to them without any issues. Repeat the same process on the opposite end. And then we need to model the supports. So that can be done by selecting the nodes on the 3D view as shown here. Click on the support. Our support is pin, so translation at AUX, UI, and UZ is not allowed. And then we say assign. You can do the same by flicking to XY. And go to the active view, which is this one, by selecting the nodes. Now we've got the structures modeled, except for those two. We need to assign the sections and run the analysis just as a test. But before assigning the sections, you just run analysis by clicking on the analysis icon. I just like for safety, I need to divide everything just to make sure everything is connected. Click on this icon. It shows you analyzing load case. And now it shows the deformed shape under the own way of the structure. You can as well just like make sure everything is making sense. We've got the frames with the bending moment diagrams, axials, reactions, easy to show. You can as well preview the results on the 2D. For example, this is the bending moment diagram. And then you can show what's happening here. This frame, the next frame, and the next frame, and so on. Reset. And this concludes the example.